Greetings of the day. Now in this lecture we are going to cover grid chamber, the next unit processes in the wastewater treatment. Where the location of grid chamber will be there in the domestic wastewater treatment plant? As we have discussed that first unit it will be a storage tank. After that it will be taken for screen chamber. Now the screening material which will be retained, it will be removed and disposed, and whatever material and wastewater has been passed through bar screen, they will come to the grid chamber. Grid chamber is nothing but it is basically a settling tank. So grit removal basins are sedimentation basins which are placed in front of the screen to remove the inorganic particles having specific gravity of 2.65, means which is more than water and up to 2.65, such as sand, gravel, grit, eggshell, glass piece, metal fragment, etc. And also non-putrescible material that may clog the channel or damage the pump due to abrasion and to prevent their accumulation in the sludge digester. So this is why we are providing grid chamber. In this particular sedimentation tank, wastewater is getting time so that the particles having specific gravity more can be settled down, and so that the load on the next unit will be reduced. Now what are the settling characteristics, means what will be the characteristics of particle. So the main characteristics of settling of particles is divided into total 4 category. Type 1 settling is considered as discrete settling. In dilute suspension, grid chamber is a good example. That means in this particular category we are counting those kind of particles which will not settle down easily, which will be normally on the upper side of the grid chamber. Type 2, it is the flocculent material in dilute suspension, and primary settling basin is a good example for that. So flocculent settling means some of the particle may have a tendency that in individual they may not get settled down, but when they are coming to each other together they may have some tendency to travel towards downward, and going forward they may get settled down. Type 3, it is zone or hindered settling, where higher concentration, higher of greater than 1000 milligram per liter, where particle interfere with each other settling, and secondary settling basin is the best example for that. And type 4, it is called as compression settling. Weight of particle causes more settling, sludge zone in clarifier. In short, how we can remember? As you travel towards type 1 to type 4, the settling capacity is increased. Type 4, it is at the bottom, where you can say it is almost a sludge blanket. It is the highest settling capacity, and type 1 it is almost a suspension, right? So it can be divided into total 4 zone. Now there are two kind of grid chambers available mainly. There are mechanically cleaned grid chambers and manually cleaned grid chambers. In mechanically cleaned grid chamber, the scraper blade collect the grit settled on the floor of the grid chamber. I will give very simple example that when you are boiling a milk, you are having a upper layer which can be easily removed with the help of a spoon, right? So same way, when this kind of layer of sludge will be there, with the use of scraper it can be easily removed. This is possible if it is a mechanically cleaned grit chamber, and the grit so collected is elevated to the ground level by several mechanisms such as bucket elevator, jet pump and airlift, because grit chamber will be normally located in such a way that bottom of grit chamber will be below the ground level. So the grit or the layer of this sludge which will be collected, it will be at the bottom part. So it is removed and then it will be elevated. And if it is a manually clean grit chamber, then it is a little bit challenging. Only for lesser area you can go, otherwise you cannot go. And when you are keeping manual cleaning, you need to make sure that at least one grit chamber as a standby should be kept. Normally also we consider that when we are dealing at public scale in domestic wastewater treatment plant, all the unit we will place minimum of 2 quantity, so that if cleaning is required, maintenance is required, or in any case failure take place, then the standby unit can be immediately operated. There are two kind of grit chambers which are mainly in use: horizontal flow grit chamber and aerated grit chamber. Here you can see one of the plan and section for grid chamber is shown, where you can see that swinging gate is kept so that the inflow of wastewater in the grid chamber can be controlled, and you can see in cross section that the slope is given, space for accumulation of sludge is given, and we are providing some amount of the freeboard also. Now again, for this particular unit we need to remember some design criteria, and as we have discussed in earlier lectures also, that design criteria will be always in a range. So length is 10 to 18 meter and depth of the liquid 1 to 1.3 meter, and velocity is controlled by means of velocity control device. Here you can see more clear cross section with all the instrumentation and required level of water. So you can see that in between the pipe which is given, that will be going to be the main operating center, and you can see that the maximum water surface which is allowed, it is always below a freeboard. Now when you have to design a grid chamber, the most important part is the settling velocity, because settling is our main criteria, main parameter over here. So how we will decide that what kind of settling velocity we can keep? So there are two equations by which you can decide the settling characteristic. Vs is equal to G into rho p minus rho w into dp square upon 18 mu. This is one equation. Another equation is Vs is equal to G into Gs minus 1 into dp square upon 18V. So whether you are having a value of density of particle and water and mu, that is dynamic viscosity, or you may be having a specific gravity, then size of particle and kinematic viscosity. By any of these two equations you can determine settling velocity. Here let's have a look on the parameter. Vs is settling velocity, dp, which is used in second equation, it is size of particle, Gs is specific gravity, rho p is density of particle, rho w is density of water, mu is equal to dynamic viscosity, V is equal to mu upon rho w, it is equal to kinematic viscosity, and G is equal to gravitational acceleration. Now what will be surface overflow rate? Again, this is one of the important parameters. So it is Q upon AS. What we have to understand, in 1 meter square area, if we are allowing 1 meter cube of wastewater to go through, how much wastewater will come out as a overflow? So where Q is flow rate and AS is surface area. Number of unit, for manually cleaned grid chamber, at least 2 units shall be provided. For mechanically cleaned unit, 1 additional as a standby should be provided. Also, let us see dimension. Freeboard of 150 to 300 mm shall be provided. Length can be calculated as L is equal to VH into T, and depth can be calculated as D is equal to Vs into T, where bottom slope shall be provided. Also, the breadth will depend upon the velocity control device which is adopted. So using this equation you can always determine L and D, and your answer should fall in a category of our design criteria which we have discussed. Again, next important parameter, it is head loss. So head loss should be 0.06 to 0.6 meter, which depends upon velocity control device adopted, and whatever grit is collected at the bottom of the grit chamber, how you are going to dispose it off? So moisture of the grit, that varies from 14 to 34%. Grit is sometimes washed after collection to reduce the organic concentration, which may be as much as 50% of the total solid. Also, filling in low-lying area can take place. Incineration, that means burning at a very high temperature in a closed tank. Also, washed grit can sometimes be used as a cover material for the screening material. Screening material means whatever has been retained in screening. If you are disposing it off as a dumping site, to cover that site, this grit can be utilized. So this is all about the grit chamber, and for further unit we'll see more detail in the next lecture. Thank you.